Okay, we are looking at topic number 22 right now, and we are getting into set builder notation. So it's just another way to write things. Basically, what we're going to do here is we're going to look at a list of elements, or in other words, just terms, and we are going to put them in set notation. Now, the question here that we're getting is basically it wants us to list all of the values of x that are an integer. And since this is a compound inequality, we're looking at all the integers that are between -5 and -1. Now, if I just think about the numbers that are between -5 and -1, I know that -4 is between, -3 is between, -2, and now we're looking at -1, and I'm just looking at the integers here. So I have to look and see if I'm going to include -5 or if I'm going to include that -1 there either. So if I come over to the side, I've got a couple things written here. If we do not have, let's see if I can find my highlighter here. If we do not have an equal sign with our inequality symbols, like we don't here, we would not include those numbers. So for example, let's see if I can change this up here. Here we go. All right, so we do not have an equal sign there. So therefore, we will not include that -5. We do have an equal sign on this one, though, so it looks like we do have to include -1 in our set. Now, the last thing you have to do if you're going to actually make this into a set is we need to add some curly brackets on the sides of our numbers. And now we have a set of 4 numbers that satisfy or create a solution for this problem. Integers that are between -5 and -1, including -1. Let's go on to topic number 23. Okay, so for topic number 23, if I'm trying to graph, first of all, this inequality, this is something that we've actually done before, you have done before, I should say, in maybe your algebra classes. But if I'm graphing that, the first thing again that I need to notice is what's happening here. We have equal signs. Now, if we have equal signs, I wrote it on the side over here, but if we have equal signs, we are going to use, oops, I erased. Let me try again. We have a closed circle that we're going to use on our graph. So I'm actually going to use 2 closed circles. If one of them was not an equal sign up here, then we would use an open circle for it. But I'm going to use a closed circle at -1. I'm going to also use a closed circle at +5. And I'm including all of the numbers between, so I'm going to draw a line between them. I'm going to try to make it a little thicker so you can see. I'm drawing a line between them because all of the numbers between -1 and 5 would make this statement true. So that's only the first part. The second part is that we're actually going to use a different type of notation called interval notation. Interval notation, as you can see, has 2 different types of ways that you can write it. You can use parentheses or you could use square brackets. Depends on whether or not you have an equal sign or not. Since both of these are an equal sign, I am going to use closed brackets for both. Make sure I can get on my pen. Closed brackets for both with a -5. I might have spread those out a little bit too far. I'll just wait. I'll do the -1 here with a comma and a 5. Basically, again, these are kind of the same thing. With the closed brackets, we're saying that it is a closed circle on our graph. So that's why we have 2 closed brackets and 2 closed circles. You would use parentheses if it was an open circle on your graph. And then just your 2 endpoints. So your 2 numbers, your 2 endpoints, -1 and 5, that you used on your graph as well. That's how you would write that. Now, there is one more thing that I should mention about this problem. If I were to change it up a little bit on you, let's say I'm going to pretend that this wasn't here. Let's say we had x is greater than 1. Now on the graph, that would be pretty easy. I would do an open circle at 1, and I would point it this way since we're talking about all the numbers that are greater than 1. When I get into interval notation, now something gets a little different though. We have to, we're starting at 1, right? and that's an open circle, so I'd use a parenthesis instead of a square bracket. On the second part, though, like on the right-hand side, we don't really have an endpoint anymore. So what we're going to use is the infinity symbol. And the infinity symbol, I'm going to do my best to draw it, looks kind of like a sideways 8. Whenever you use the infinity symbol, since there's not really a number, there's not an ending, we can't use the closed brackets with an infinity symbol, so we would use this. If this was pointed the other way instead, if I pointed my line this way, it would look like this. I would use a negative infinity, sideways 8, a negative infinity with that parenthesis, and then the high end would be that 1, and I'd have to use a parenthesis there too because it's not a closed circle. So these are the two ways you would write it depending on which way your arrow was drawn. Okay. Topic number 24. We are into union and intersection sets now. As you can see, I've got some notes written on the side. When I'm looking for union, I'm looking for all of the elements from both sets. So I've got two sets here. I've got a set with those letters, and I've got a set with these letters. And when I'm doing the union, which is this one, we're going to actually start with the union. I want all of the elements from both of those sets. So I'm making a set with the curly brackets again, and I want every single letter that I see up there. So I see A, I see a K, I see a K, I see a J, I see an E, I see an F, and I see another J, but I'm not going to write J twice because it's just elements in the set, so I just need to list them once to say that they're in one of those two. So you don't list things twice with this. Also, I don't have it in alphabetical order or anything. I don't know if Alex is going to require that. You can try it in alphabetical order or try it not and see if it changes anything, but I think this is just fine. Let's go on to intersection. An intersection, if I'm listing points in a set, or elements in a set, I want only the common elements. So what do you see that's common from these two? I see a J that's in both of them. That's the only thing that's in both. Otherwise, everything is just individually in one. So that's actually the final answer for topic number 24. Moving on to topic number 25. I have the same notes written on the left-hand side, just as a reminder. But first of all, let's look for union, all of the elements in both of the sets. This one was actually a little bit easier for me to do if I drew a picture first. So if I just quickly draw a number line, and I put a 4 on it and a 7 on it, then I can use my open or closed circles. So for the 4, I would use the closed circle. For the 7, an open circle. And it says V is less than 4. That means I'm pointing my arrow to the left. And for the 7, I'm using an open circle, so I would point my arrow, it says V is greater than 7, so I'd point my arrow to the right. Now, it says I need elements from both sets. So this is going to be tough because I've got a lot of elements over here and a lot of elements over there, actually infinite on both sides. So I'm going to have to use my interval notation that we did on the problem 2 problems ago on topic 23. My interval notation looked like this. So for the left one, I had a parenthesis because I'm going to need to use negative infinity. And it goes all the way to 4. Now 4 was a closed circle, so I'm going to put a square bracket around that. On the other side, 7 is where it starts, and it goes all the way to infinity this way. Well, 7 was an open circle, so I have to use a parenthesis, and I always use parenthesis with my infinity symbol as well. So this would be a union, so I'm going to put a U in the middle. Again, union means all of the elements from both sets. Basically, I could pick any number less than 4 or any number greater than 7, and it would be a solution to this question. For an intersection, now an intersection is just an upside down U. They just switched it upside down. And this one's looking for common elements only. Well, are there any numbers that you can see from my number line up here? Are there any numbers that satisfy both of those arrows? Well, I don't see any because there's no space between them. So I would say it's an empty set, meaning there isn't any that would satisfy both. So this one is an empty set, and you would write that with a circle with a line through it. That's it for topic number 25, and I think that's all for today. Thank you very much.